Okay, everyone, please get seated and prepared. I'm happy and very glad to announce Simon Kendall, the Consul of the UK. We, as Vito Ventures, we have a good relationship with the consulate here in Munich, and we partner in the context of deep tech startups and innovation in UK and here in Germany. And we have a super good exchange. Some top UK startups from quantum computing, later AI and autonomous driving will be here. And I'm happy to hand over to Simon to talk about deep tech startups in UK. Thank you.
Thank you. Oh. Thank you for that generous introduction, Herbie. It's fantastic to be here at the largest and most influential pure tech conference in Germany. Quite apart from the reputation of the sponsors, the fact that there's 1,200 delegates expected today is testament to just how engaged and passionate the tech community is. So my name is Simon Kendall, and I am the British Consul General for the south of Germany, based in Munich. And the job of a stuffy Consul General in Germany is not just to support British people into distress and go to parties and drink champagne. It's also about strengthening the prosperity and research and development links that bind our two great nations. The UK and Germany, and especially Munich, see clearly the opportunities and challenges of technology and how it is changing the world before our very eyes. Today, I will try and set out the UK vision and what we are aspiring to achieve as a nation for the future. And we want our close friend Germany to be our partner of choice in this journey, on this journey. It's nearly 70 years to the day since Alan Turing's groundbreaking report to the National Physical Library entitled Intelligent Machinery was written. A report that was breathtaking in its vision, its confidence and intellectual fizz, setting Turing on his way to building actual machine intelligence. And the rest is history. And here we are today in direct descent with a renewed understanding that the momentous potential of AI and the data revolution will bear fruit when all of us, brilliant scientists, businesses, startups, governments, all come together. Now, the UK and Germany are streets ahead when it comes to deep tech technologies, such as the Internet of Things, autonomous cars, data analytics, artificial intelligence. And at a regional level, in terms of technology, talent, and research, Munich and London are world-leading and sit at the top of most global rankings. But if you'll indulge me, let us focus on the UK just for a second. The UK's technology sector has seen remarkable success and now counts as the largest and fastest growing in Europe. We have a strong startup culture, bolstered by tech clusters across the UK, government investment in innovative technologies, and an active venture capital community. London alone has 155,000 tech-based employees, 42 of the UK's leading 100 tech companies, and over 50 incubators, accelerators, and innovation centres. The UK has this unique tech ecosystem consisting of an open economy, world-class universities, investors, capital, accelerators, networks, and talent. This bright and diverse ecosystem is essential if one wishes to start a company or raise capital. Now, the figures speak for themselves. I mean, venture capital investments into the UK's tech sector reached an all-time high in 2017, with UK firms raising £3 billion worth of capital. This is almost 4 times the amount raised in Germany, more than France, Ireland, and Sweden combined. And amongst these figures, London stands out as the prime tech location. However, it's not just about London. The UK regions have just as much to offer. Only 32% of startups in 2016 in the UK were based in London. The other great cities in the UK, such as Manchester, Birmingham, Leeds, have vibrant startup communities, and each host and each host tens of thousands of digital jobs, soon to be bolstered by huge infrastructure investment, such as the HS2 rail network, that will connect all of these great cities in the north and unlock their economic potential. And further south, of course, but in the west, we have Bristol, Oxford, Cambridge, all of which are world-renowned hubs for tech innovation. Artificial intelligence. There are not many moments in human history where a technology turns up that changes everything. The wheel, the printing press, electricity, those delightful self-service checkouts found in most British supermarkets. AI is one such technology, and it will be revolutionary. And the UK has established itself as a global leader of AI in research and commercial use, with leading academic and corporate research groups such as UCL, Oxford, Cambridge, University, Google, DeepMind are all based there. And today, there are over 400 AI companies in the UK. We're seeing tremendous growth in this sector. It's unbelievable, with one new AI company founded almost every day in the UK, covering key growth sectors such as healthcare, cybersecurity, financial services, retail, marketing, manufacturing, autonomous driving. The UK, an open country and economy, and AI development and application is flourishing there. In fact, 40% of London-based founders came from outside the country. What about Brexit? People are asking. What are the implications of Brexit? Well, in March 2009, yes, the United Kingdom will leave the European Union. We will not be leaving Europe. And with our shared values of democracy, tolerance, equality, freedom of speech, support for the rules-based order and international institutions, we will continue to work in close partnership with our friends in Europe and in Germany. The UK, I can promise you, will remain the same globally minded, outward-looking and welcoming country it has always been. It will also remain globally competitive in tech, helping deliver health, prosperity, security for all. And judge us not just by our words, but our actions. For example, we have doubled Tier 1 exceptional talent visas to 2,000 a year to attract the best and brightest talent in science, digital technology, including specialists in AI. But despite our openness and the confidence that we have in the future, we do need to upgrade our economy, version 4.0. For the transformation that is coming. And we have set ourselves the grand challenge of putting the UK at the forefront of AI and data revolutions. The British Prime Minister has announced her own moonshoot mission of using AI-powered early diagnostics to revolutionize cancer treatments in the UK, with 20,000 more 5-year survivors by 2030. And some of you in this room may even be involved in reaching our ambitions to increase probabilities for common cancers. The opportunities for AI run deep throughout our new industrial strategy, which facilitates a far-sighted partnership between the public and private sector, universities and civil societies, backed by £7 billion of public R&D investment. And through this industrial strategy, the UK will also invest in skills and education, building on the AI master's programs and AI-related PhDs. We will invest to ensure we have the infrastructure in place, which is pretty good at the moment. I mean, the UK is already supported by a super-fast broadband network available to 91% of all UK premises. But we will engage also with regulators to find imaginative ways to be innovative friendly and set up a new centre of data ethics. And for those interested in the UK, its thriving tech ecosystem and our world-class companies, the British Consulate's tech team, and yes, we have a dedicated tech team at the British Consulate General in Munich. Frank, Jane, Ben, who have their hands up, are all here all day today to talk to you about UK as a business location and how to meet, but also how to become the most innovative and fastest growing tech companies in the UK and possibly the world. So please do find them, talk to them. So, before I hand over to the panel, which I'm very excited about, I'd just like to say a few words about the 4 exceptional UK deep tech companies presenting today. I really think it's worth me doing this. So you've got Oxbotica, who are a spin-off from Oxford University, a world leader in mobile autonomy. This is a company working with technology that can be applied not just to cars, but also cargo pods, forklifts, and the Mars rover. Cambridge Quantum Computing, which has designed a proprietary operating system for quantum computers. I don't actually know what that means, but it's pretty impressive, I'm sure. And then you have ObjectBox, has developed a revolutionary object-orientated database for the Internet of Things and mobile. Prowler, lastly, which are on the panel, which is following me, has developed a platform for AI decision-making, which can be applied to finance, logistics, and autonomous systems. So there's some real innovation here, there's some real energy there, and as I said, a lot of it goes way beyond a poor civil servant like myself, but I know it's exactly these sorts of things that are going to change the world. So do find them, talk to them. In this environment, we'll all benefit from interaction and engagement. And finally, I simply wish to say that together we can build the talent, invest the tools, solve the big problems of humanity, and align all this with the public good. We want the UK and Germany to be partners together in delivering for the future, and this great conference is a stepping stone in achieving this goal. So thank you very much, and wish you all a good day.
Okay. Thank you. 1 second. Maybe your colleagues, Frank, can you come up, both of you, to stage?
Gosh.
Just as you mentioned them, if you have something to do in the
Come on, Jane. Let's.
I'm sorry, I just knew Frank's name, so
Oh,
I
sorry.
couldn't mention you.
Frank,
the team.
Ben, Jane.
Whenever you plan something to do in the UK, or vice versa, please speak to those people. Thank you for coming.
Thank you, Herbie. Thank you. Thanks very much. It's really fun.
Okay, so can we put the table away? So we continue directly with the panel on AI, which will be moderated by Alexander Waldmann from the Applied AI Initiative. This initiative is a consortium of industrials and academics that try to support or bring AI research in Germany to the next level. And I'm very happy to have Alex supporting us here on the panel. And please come to the stage.
Hey everybody. Ooh, a little loud. Yes, I'm Alex. First of all, thanks for the organizers for inviting me. Thanks to you for being here. This is going to be exciting. I heard the word ecosystem quite some time in that speech. So on this panel there will be 4, let's say, major ecosystem players. Little smaller ones, little bigger ones. I need to get a feeling for the crowd. So who indeed, since this is a developer conference, so I'm a computer scientist. Who has a developer background here? Okay, that's roughly half. Who has an entrepreneurial background? Okay, that's the other half, I guess. Maybe shout some terms at me. What is in the room? Probably computer science. What else? I'm going to stand here until someone says something. What is out there? Math, maybe. Physics, very nice. What else? Do you have people from the business side here? Lawyer. Lawyer, very nice. Okay, cool. I will just invite you guys up. Come join the stage while I talk a little. So how is this going to work? My job is very quickly to fade into the background and let these guys have a discussion. As it was introduced, I'm representing as the operative director Applied AI, which just tries to lift the whole country into the AI age. This is our mission, and these are the guys who technically are capable of doing it. So my task will be to kind of be the broker for their message. We have on the panel these 4 gentlemen. I will introduce them, and maybe you guys give them a hand once I'm done with each and every one. The first one is, and I need to spell this correctly, Vishal Chatrath, very nice, from Prowler. He's the CEO and co-founder. The world's first principled AI platform for generalized decision-making in high-dimensional dynamic systems, such as financial markets, smart cities, logistics, transportations, and autonomous systems. This is what Prowler should be, and maybe you can give us a few insights look towards that. Give him a big hand. Then the next is Marco Maier from Tawny and head of AI at Hive. Marco is a technology researcher and entrepreneur from Germany, so that's kind of visible there. And he's excited about how humans and technology interact with each other. He received a doctorate from the University of Munich in the field of context-aware systems and later joined Hive, the innovation company, as head of artificial intelligence. I'm not going to tell too much about Tawny. I already know it. You can later tell the audience. Give him a hand. Then we have Ronnie, the CEO of Microbes Industries. There's not too much about to find you online, so maybe you tell us your inside story. As far as I know, you graduated from Humboldt University in Berlin. You have a major in philosophy and computer science. And you were the head of software development at Textry before you went to build up Microbes Industries. And then the last one, sorry that I have to read this all, but it's a lot of knowledge to digest. Christian Thurau, the co-founder of 20 Billion Neurons, one of the really well-known startups in Germany by now. Christian is co-founder of 20 Billion Neurons, a Berlin and Toronto-based computer vision and deep learning startup. Before that, Christian co-founded the game analytics startup Game Analytics in 2011. He holds a PhD in machine learning and has published more than 50 scientific papers on a broad range of topics, such as computer vision, behavioral modeling, robotics, data mining, and much more. So now that I had the pleasure to tell you what these guys are about, we go in turn, and before we go into the discussion, you maybe tell the audience what exactly your companies do. Vishal.
Thanks for the invitation, and I should use the mic. So I think I got a good flavor based on the early questions on the makeup of the audience. How many of you are broadly familiar with artificial intelligence and machine learning? Fantastic. So the field of artificial intelligence, it's a big field. There are kind of lots of areas, and what we focus on in Pollard IO is principally on making decisions using machine learning and AI. And our thesis when we started the company, and the background is the previous company I was involved with was making decisions for voice dialogue systems, which was sold to Apple about 3 years ago. We wanted to generalize the idea of decision-making across all industry sectors, because our thesis was that while the changes in different industries are there, the basic principles under which we make decisions as humans, they don't really change. And what I mean by that is essentially any kind of agent or human or any particular agent in the environment, when it's really making decisions, what it's really doing is making sequential and strategic decisions in an uncertain environment in the presence of other agents. So when we came up with this thesis on doing that, it became very clear to us that we will have to step back and think about combining almost the fields of mathematics that have been independent for the last few hundred years, namely probabilistic modeling and the precursor to reinforcement learning, and also things like game theory. And what we've achieved till date, we are about 2 years old. We have a staff of about 90 based in Cambridge, UK. Till date, in this field, we have published 27 papers. The staff consists of 41 PhDs. We filed about 4 patents. And this year, we are deploying the platform in finance, specifically focusing on portfolio management problems for futures and equities, and also last mile logistics. It obviously begs the question that why these two? So the idea was to pick up 2 as different fields as possible to prove that we could generalize the principles of decision making, and now we have about 80% commonality between these 2 areas. And we are also in very kind of early stage of piloting in genomics and fast-moving consumer good industries, which will be deployed in 2019. So I think I've taken too long for an intro, but
That's just fine. 2 to 3 minutes is.
Okay, servus everyone. I'm Marco from Tawny. And what we do at Tawny is basically we're working towards making machines empathic. So we're trying to introduce the notion of emotional intelligence that we as human beings have in our interactions among each other in human-computer interaction. As we see the future, there will be two large areas how the world will develop. We will have some areas that are probably completely automated, like only robots, only software, whatever. But there will be a very, very large area in our world where technology and humans will live together, work together, form some kind of coexistence. And we think in this area it is very important that, for one, we as human beings learned how to live together with machines, with technology, and on the other hand, enable the machines to take a step towards the human beings and understand human beings. So what we do from a technical point of view is, in the first part, we're actually trying to recognize human emotions or human affects based on a diverse set of sensor data. So, for example, physiological data, things like heart rate or skin temperature or skin conductance. Of course, we're also using visual data like video from your face or analyzing body posture, analyzing speech, voice, text, whatever it's out there that gives us a clue about how a human being actually feels, what's going on inside the human being so that the technology can react appropriately. We're based in Munich. We're a team of 5 right now in the core team with some external guys helping us. And just to give you a very small example of what we're doing, for example, we've worked together with professional biathlon athletes, equipped them with sensor devices, and were able to actually predict if they will hit the target when they are shooting before they actually shot. So just based on their inner state, their physiological state, we're able to somehow predict if they will be successful or not. And this now is used to improve their training and make them better to increase their performance. Yeah.
Okay. So microbes industries, what we're doing is we're essentially letting robots learn or train robots to perform proper hand-eye coordination. So today, industrial robots typically just make completely pre-programmed movements and just go through a number of positions and don't really react to their environment. So for the more technical people in the room, I'll just push out a couple of buzzwords. So what we're doing is learnable, trainable, real-time motion generation for trajectories for industrial robots. And you would apply that in manufacturing. So whenever you have a manufacturing problem that you want a robot to perform, and you have to deal with variance, the light changes, the colors change, you're dealing with a fiddly bit, like a cable or a soft part. Today, industrial robots can't solve that task. And with our product, which is just a controller with a bunch of cameras, that you hook up to the robot and then show to the robot how a good movement is made, the robot can perform that and solve the manufacturing task. We're based in Berlin. We're 15 people plus a couple externals. We've been around, and interestingly enough, I have a lot of questions for you. I started my AI career as doing something called the Artificial Emotion Project, dealing with very similar questions.
Interesting. Morning, everyone. So my name is Christian. I'm the co-founder of 20 Billion Neurons, and we are a video understanding company. So that means that we try to teach AI to understand what humans are doing in videos. So to give you some example, for example, currently we have AI that can understand human hand gestures so that you can, for example, control your laptop or some other device with that by just making a gesture in the air. We have AI that can understand inside a car what the persons there are doing. So this is an important application for robotaxis in the future, where when you lack the control instance of the taxi driver, you still would like to be able of understanding what the passengers are doing. And this is, for example, recognizing, if people are having a heart attack maybe, or if people are eating or drinking, or doing certain other kinds of activities. So we are working on that now for the past 2 to 3 years. And I think it's fair to say that we have now one of the most advanced artificial intelligences for really understanding human activities and motion patterns in video data. So how come that we have developed that and not someone else or Google or Facebook? So our approach is actually deeply rooted in data. So, and a lot of what has happened over the past years in machine learning and AI is only possible due to training neural networks on vast amounts of data. And for these types of activity understanding or understanding of motion patterns, there simply wasn't always enough or sufficient data there. So basically we don't have good data samples or good video data to teach machines how it looks like when someone is drinking a coffee, so that the machine can successfully infer from the data how it looks like when someone is drinking coffee. So to explain our approach, so what we did is that we train neural networks with really vast amounts of video data, and we generate the data ourselves. So for that, we have started to develop 2 years back what I like to refer to as the largest movie studio in the world, which exists in the cloud, where we have more than 20,000 amateur actors that we pay to perform certain activities in front of the camera. So this really sounds like a moonshot mission, right? So when we want to teach the AI how it looks like when someone is drinking coffee, we pass that label, drink a coffee, to thousands and thousands of crowd actors all around the world. And they then film themselves or someone else while performing this activity. And based on that, we were able of generating one of the largest data sets on human activities and gestures in the world. It currently covers a couple of hundred different actions, going from simple hand gestures to human actions like eating, drinking, sitting, running, to interactions of humans with objects. So we have tons of videos where people are just dropping objects. So from that, the AI can learn that that an object is always falling to the ground and never to the ceiling. So to infer gravity from that. And, but I probably also took too long. So currently we are now mostly concerned with finding the right use cases for this this technology, and we are now looking into different verticals. The automotive industry is one of them.
So this is very nice. So each and every one of you represents kind of a central capability of a, not going to say the word, a more advanced machine learning based AI system. And each of you is taking a different approach, right? You're coming from the emotional side, you're coming from the vision part, you're looking at collaboration, your decision making. So since this is a developer track, what are the technically currently hardest hurdles, the hardest part in what you're working on? So for example, you published you're opening up these data sets to the public, right?
Yeah, that's true. So we have released parts of our data set to the public, not all of them, because, I mean, all the founders come from the research community. I, for example, worked for 10 years in research, and we want to give something back, of course. So we just also find, of course, useful when people are playing around with our data, and also the research community is really eagerly looking always, of course, for new data sets. Yeah. So data is really a big deal, I think, nowadays. Yeah.
How does it look from the emotional side? I've seen you work on sensing systems and so on, kind of agnostic to the system.
Yes, I can totally agree. So data is, at least in our domain, it's the main problem. So because, as you can imagine, getting like physiological data of actual living human beings is not something you just can download from the internet. We have to also use a friendly crowd while recording this kind of data for us. And from a technical point of view, the hardest stuff we're dealing with right now is since there's always too few data points in our domain, we really have to find ways to get the most out of the data we have. So doing things like transfer learning, weak supervised learning, active learning, generating data sets, whatever. So the whole toolbox that's out there, trying to, somehow get every little information that's in the data and make it useful. That's actually what we're trying to do right now, and what's probably the hardest part of doing it.
That means you are indeed, a question goes to everyone, working in experimental fashion, experimental manner, rather than a clear road line, defined kind of process, what to expect after 1 week, 2 weeks, and so on, like you would normally do in software development?
So I guess that's probably quite true, because if you had that level of forecasting ability to know what's going to happen after 1 to 4 weeks or 6 months, then I think by definition you wouldn't be doing anything new. Because to do something new, there has to be a lot of uncertainty in the system. Otherwise, as the gentleman from kind of 20 billion neurons pointed out, that the big guys would be doing it, right? So one of the things is that why we are able to innovate is we can really step back and really think in terms of what are the challenges. So I think that also puts us in a tricky but fun situation that as an entrepreneur, you have to be able to handle uncertainty in a very good way. So if you are hoping that your world will be very kind of deterministic using the machine learning language, then it's not a good place to be. Based on the technical challenges, if I'm able to say that, and I'm sure these guys will appreciate, is that this field is so greenfield that it's almost, no matter what we do, we end up with a research paper. So when we ended up with 27 research papers, my investors keep asking me that, oh, why are you focusing on papers? No, we are not. We're trying to solve a problem for the last 2 years. And just because of the greenfield nature, it just kind of generates, bits. And for us, the biggest technical challenge was our team is it actually comes from very different branches of behavioral sciences to different forms of machine learning, all the way from probabilistic modeling to reinforcement learning to multi-agent systems. And people who are very familiar with this will realize that people from probabilistic modeling, RL, or multi-agent systems in the university or in academia, they are part of different departments. They just don't use the different words to describe the same thing. They also use different mathematical symbols. So our first challenge was how to get everybody in the same room and agree that an alpha means the same thing for all these different teams. To agree on what's an agent took about 4 weeks, right? So this is just the kind of challenges, but it's fun.
So that's very interesting. So research is an inherent part. You are heavily nodding. So
yeah, two things. So one thing I'd like to add is this fact that if you're doing innovation, you sort of need to do experimental development and can't fully plan out when your software development will be done, is not something that's in any form specific to AI. I mean, this is really true for anybody who does anything that hasn't been done before. And we sort of got into the habit in Germany of referring to software companies as tech companies. And there's really a huge difference. If you can't plan when you'll be finished, you're not doing innovation.
Yeah. I think also it's really important to note that AI, as you also said, is really in an early stage right now. I mean, it's not exactly, I think it's a bit further maybe. So if you would compare it to the internet, it's probably where we had been maybe in 1998 or something like that, right? So before we have figured out all the different business models and the technology was still pretty early. So I think it's also quite normal nowadays for startups to really focus also on research, which we also do. And if you have a look, we're not, right now, I mean, I don't want to say anything bad about the universities. They are doing really great research. But since there is a connection between data and AI right now, you can see a lot of important research coming out from the industry, from the big enterprises, but also from startups who have figured out how to access the data sets, whereas from universities, people rely mostly on freely available data sets. So there's really a shift going on, I think, and this might be mostly because to the availability of data too.
Yeah, I mean, I can also second that. It's really, this showed up in what everybody said here, right? Data is the crucial issue. I mean, for us, it's so hard that we're even, recording the data on site in the product. Because, all the industrial robots that move today all move in the same way. That's the point of them. So there just isn't variance in how robots move today. So the only thing we could do to even, get to a first set of data to learn something from and to generalize over is to make the data gathering the product. How would you ever do that from a university where you need to spend insane amounts of money on physical robots doing physical things in factories that you have no access to. So to get this machine rolling where data comes in, and you can do machine learning on data of actual production sites, you sort of need to, your first product very obviously, and that's where we ended up, is take the machine learning to the factory, record the data there, solve the problem, and then you have something to work with in the first place.
Yeah, so I guess just to take a slightly extended view about this kind of data problem. So what we saw, at least on our side, one of the first tasks we did was to create a simulator. And for us, it was important because there was no existing real-world environment where you could use some data to essentially build an environment simulator that was high-dimensional. So effectively means that you literally have hundreds of parameters that are changing every second. To take your guys' example, everything from your blood pressure to your emotional state, because once you have to kind of detect that, it becomes like a high-dimensional problem. So what we've seen at least is many times if you have a good problem formulation, you can kind of get around the problem of data by simulating it and generating synthetic data, so at least you have some semblance of things in practice, which you can test later. But I agree with you that there is no shortcut to having actual data, but it should not stop people. And I hope all of us will have our eureka moments as we go forward with our research. Not all of them will involve a bathtub, but I'm sure they'll be fun.
That's a good point, I think, also, right? Right now, you also see a lot of startups and other companies thinking about novel ways in how to create data. And I think that synthetic data is actually also could be really crucial in the future. I mean, it already is in certain fields. For computer vision, for example, it's still a bit difficult to use purely synthetic data. So what people are doing, for example, for self-driving cars, they're using a video game engine, and by that trying to simulate traffic scenes, from which they then can infer, certain types of sensors to actually train their models, which makes a lot of sense. But since people already only started 1 or 2 years, or say 2 to 5 years with that, it's still not at the level that you can really compare it to real-world data. But eventually, we will be getting there. But I think the question on, finding novel and creating ways for creating data, this is I think a crucial aspect for the next years, next to the algorithms, right, which are also still not in a stage, I would say, where everything is solved. So also when you have the data, it doesn't mean that you have the right algorithm to actually train your model with that. So both aspects are still very important, I think.
So let me drill down a little, because as a developer or someone who has built a lot of stuff and worked with lots of teams, it seems to me that this 80s, 90s style infrastructure layer is kind of the same, right? Centralized hardware, these very hard to get specialized compute environments. Do you get a DGX? Do you have access to these kind of systems? And on top of that, everybody seems to be building their own tool chain. It doesn't seem that there is a kind of set level of tooling in AI. Sure, there's TensorFlow, sure, there's Caffe, but what is your approach to these kind of questions? You have to acquire data. So how do you go about this?
So I guess with tooling, and it seems like I am definitely the oldest one on this panel. So you have the benefit of the fact that you've been through a lot of industries where when we started, there was no tooling. So when I started my career in 97, even these software development environments for C++ were like all over the place. And now you have, it's all very standardized. I remember in the very early days of 3G and Bluetooth, it was a complete mess. That's gotten standardized. So there's an evolutionary process. Part of that problem will be solved by standardization bodies. And I think a big part of it will be solved by people just pushing out tools for the community that will become de facto. So TensorFlow is a very good example. And then you have PyTorch and things like that. What we have done as a company, on top of TensorFlow, we have created GPFlow, which is essentially like a TensorFlow sort of environment for actually probabilistic modeling. So I think that's what a lot of us will do for the community. But of course, there has to be some sort of a business logic around it. So the fact that we are kind of pushing out GPFlow together with people in Cambridge University is not that we are a charitable organization, because it makes kind of business sense, because it allows other people to innovate on top of it, whose code we can use, and vice versa.
Yeah. Marco, what's your perspective as you have inherently to get data in the kind of things from the subject?
Yeah, regarding the sensors, it's a complete fuck up. So everyone is his own proprietary, like maybe they have an SDK, usually they do not, then you're off to maybe reverse engineering what they're doing there. So the sensor part is a complete mess right now. So what's of course is better if we're using other more standardized sensors like cameras or microphones that just work. Regarding the machine learning tooling, I think actually compared to what was there like 5 or more than 5 years ago, there's a kind of good state right now. I think with like TensorFlow, PyTorch, Keras, whatever. There's this base set of libraries. The community mostly has agreed upon. And I think the next layer of abstraction or tooling does not make really sense right now, because there's so much like things to figure out where we should go, where different use cases should go. So I think the level of like abstraction and standardization is quite right at the moment. So it's really something we have to work with, and I'm always skeptic if I see like very high level standardized machine learning APIs, whatever, that I don't think they fit any use case except the very, very, very specific one, like recognizing cats and dogs in an image or something like that. So I think that the tooling is actually quite good right now that is available.
Yeah, the sad truth is that what we do in AI is essentially just math. And what TensorFlow and the similar frameworks give you is a math compiler that makes executing math fast. And I also seriously doubt there's much commonality over just a certain type of mathematics, a certain type of multiplying stuff together that is above and would benefit everybody in AI. I just don't see it either.
Still, you're developing a kind of software tool for robots that runs behind this, right?
Yeah, and then if you go deeper, I mean, AI is very broad, right? So many people are doing very different things, calling it AI because there's neural networks in there, or there's decision theory in there at some point. So if you go deeper and if you go slightly more vertical, then of course you start building your own frameworks, and then some part of it from below gets replaced by just TensorFlow going there. So when we started 15 years ago with what we're doing now, we thought we needed to do some of the things that now TensorFlow or Theano before that did. So at some point we abandoned our own stuff and said, let's just roll with that. And then there's a layer that's specific to what you're doing, right? If you're executing movements on industrial robots based on camera images that you get in, you very obviously have a problem of pushing a lot of pixels through neural networks very fast and translating it into robot movements. And then, of course, there's a software framework that makes sense that. And as you said, of course, we're pushing ours. We're hoping that people like it and it makes sense to them, and we get a developer community going at some point. But this is already very specific. It's not AI tooling. It's really situating agents in dynamic, continuous environments that may be physical or virtual, etc. And you're already in a very specific field that, for instance, if we went into finance, I don't think our framework would make much sense.
Yeah, again, I can see the point that there would be kind of limitations. However, there are certain kind of areas, and I think it's from our perspective, because we work backwards from the problem statement, and what we've seen, and again, it's not universally applicable, as you said, is that the time series components that we have on our platform is the same time series components we are using for the stock market and also for modeling the portfolio of a fast-moving consumer goods company. Because ultimately, whether you have stocks or futures or shampoos or anything, basically selling, it's the same kind of time series data, and then making it high-dimensional. Similarly, one thing that actually surprised me was we had created something called tunable AI, which essentially allows to tune the rationality of the agent inside an environment based on the environmental factors. Initially, we had built that component for the games industry, which we were just kind of fiddling around with. And eventually, that became very effective as an agent that does trading and portfolio management for our finance customer. So we've seen that, but part of it is by design, but I must admit, a lot of it is also by accident. We had that component, we thought we'll give it a shot, and it worked incredibly well. So did I plan that? No. It happened by accident. Yeah.
Yeah, that seems to be a recurring pattern. I mean, there are two things I want to follow up with, and I'm going to say both. But so the first is this, because it begs for me to ask this. I've seen friends from Google and Microsoft in the room. So might you just very quickly comment maybe on your view on those general capability-based approach of those commodity APIs, if you will, because you're all arguing towards a kind of verticalized software stack with maybe a base layer on top. Maybe you can jump in there and give us a feeling for what's your perspective.
Yeah, so maybe for us it's a bit different because we really rely mostly on deep neural networks. So for us it's mostly about training a network. Then you have all the important and difficult to engineer components in there. We can take the network weights, and then we just need to plug it into different kinds of systems. So for example, for us it's important to have it run on an embedded system, on a smartphone, or on a laptop or whatever, right? So for us, more the difficulty is to find the right framework to actually transfer or find the right underlying platform that makes it possible to run the network on these different kinds of platforms. So, and this is actually to some extent also, I think, the beauty of deep learning, or deep neural networks. If you think a bit about it, like software engineering 2.0 or something like that, it's more about you can just take these things, they do a certain task, and you can just take that and plug it into all kinds of different platforms. So I'm not that much concerned about that, to be honest. So right now, what's more difficult to us is really to have the interface to the different platforms, which is more difficult and still takes a lot of engineering effort. There are now certain frameworks, like for example, Onyx, who claim to be able of transferring between the different kinds of neural network frameworks that you have. They only work to some extent, but they're still under heavy development. So this is, I think, could be I think, a trend for the future.
Anyone?
Yeah. So I guess so there were two parts to that kind of question and answer. Kind of one after the other. So first is this general trend towards platformization, and I think that trends toward platformization of any industry will happen and will always happen, and I think machine learning is not immune. It's just a matter of how long. Again, when I started my career, I used to carry a pager, a phone, and I also had a fixed phone. I had a CD player. I had a newspaper in my hand, and so on and so forth. And when I give my presentation in the afternoon, I show those 16 circles, which I used individually over the past 20 years. And I carry the functionality of all those in my phone these days. So platformization does happen. And I also believe that as we go forward in the next 5 to 10 years, there will be platformization of AI and machine learning. You will have multi-use kind of components being combined together. It'll happen with some innovation, mainly from people like us from startups. A lot of the stuff that we do will be acquired by larger companies. We'll all make a lot of money, but that will go into the platforms. The part of the big players, and I think that's probably the most important, and I don't know of a single company ever that has reached a scale like the big ones and has disrupted the industry, because it will not happen. I don't believe the Googles or the Microsofts of this world will be the big players in AI and machine learning. And the reason why I say that is it's this very typical innovator's dilemma. So one good kind of data point here is we've just about to publish a paper that shows that by combining probabilistic modeling and reinforcement learning, you are able to make the efficiency of learning 3 orders of a magnitude faster, even in simple environments like this inverse kind of cart-pole problem, which these guys are very familiar with. Now, that's for a simple problem. As you go to more complex problem, we believe that orders of magnitude in terms of efficiency of learning will go even higher. So think about the impact of this. So if you are a Google Cloud or your Amazon Cloud or Microsoft Cloud, it's your worst nightmare. Because with the efficiency in learning, you had thought you'll make $1,000, you'll make $1, right? And as the environment becomes more complex and you go to 4 or 5 orders of magnitude, you thought you'll make 10,000, you'll make $1, right? So it is. I sincerely believe in existentialist crisis, and they cannot market these more efficient algorithms, otherwise they'll be screwed, right? And you can see it actually doesn't require a genius to kind of figure it out. You just have to go to the annual report and see which is the biggest growth area and contributor to their revenues. What is kind of underlying their stock performance is the future of their cloud business, right? They will not sell you efficient algorithms, we will.
That's a strong sentence. So coming back to what you guys said in the beginning, that research is an inherent part of every startup and research is an inherent part of, yeah, exactly. So my question goes into this direction. So there are entrepreneurs in the room. The typical notion is, can I afford to research for quite some time if that phase is longer? What is your perspective on, I want to found a company in that area? How did you guys do it with that notion that for the moment you will have to do experimental stuff, research?
Well, for us, we're kind of in a special situation because we're very tightly related to Hive, which is an existing innovation company, which allows us to do more researchy type of client projects based on their existing customer base. So this allows us to keep going, trying things out with actual clients that are probably more willing to allow us to do this kind of high risk stuff because there's an existing partner relation they had with our mother company. So this is one approach that could work, just to set things up in a way that allows you to sustain the company for a certain time and trying to figure things out. For us, at the same time, it's not just that we want to do research because we were interested in it technically. It also is very important for us to actually define what the actual use case or the actual product then could be, because I think that applies to most of us from the developer side. We're usually very fascinated with the tech stuff and can get very excited about certain things, and the world simply does not care about it. So you just have so it's very important to have this kind of project with actual clients telling you, okay, come back in 6 months when you have something actual to offer and not just some vague research stuff. And this helps a lot to actually get into a state where you have an actual product or vertical you wanna aim for as a first target market.
Yeah, that probably, doing technical innovation, actual deep tech innovation is hard, and it will be very expensive. You will see that if you do it, you will notice in your cap table. So if you're in there for quick money, do business model innovation, then you don't have to do deep tech. However, deep tech is awesome for a number of reasons, and it's not just that we like to play with interesting stuff because we're all research or engineering backgrounds, and this is just much more exciting than the pure business model innovation. The other thing is, if you're getting it right, you're actually doing something transformative, and then maybe the cap table doesn't so much matter because you're working on something big. And if you're prepared and willing to do that, and are willing to risk to fail there, then really thinking backwards from, make an assumption about the future, and try to imagine a future where a certain thing happened. For instance, robots are common, and then try to think backwards and say, okay, what needs to happen for this to be real? And then you need, if you do that, you sort of know what you're going for, and then your risk is not making it because you're too stupid or you don't get the money. All this can happen, but at least you're working on something that's worth doing. And this, I feel, even if you fail as a business, you didn't fail as a human.
I think also that, very good. I think also that with the machine learning, what is probably also different is that up to 5 years ago, this was only happening in research. So now what you could see afterwards is that a bunch of people coming out of research founding startups because they could see how the future will look like in this field. And this is what we are seeing right now. But this doesn't mean that all the problems are solved. So research is really, it's really an integral part of AI and machine learning for the next probably 5 to 10 years. Just because now also startups are doing it doesn't mean that it is a bad thing, right? I mean, it costs a lot of money. It's at this stage, I think it's still very difficult to convince investors that it is the right thing to invest in research and to invest in these companies. But this is, of course, the thing that every founder has to do, and it's really hard, right? Especially, I would say in Central Europe, it's probably even more difficult than it is in North America, where there is this more, engineering thinking. Already present, but also in Europe, this is changing a lot, I think, because people are seeing the success stories. They are seeing that AI startups take maybe a bit longer until they can really take off, because now until the Series A, often people are still working on the product, on the technology. So this is not like your standard, dog food online shop where you use the Series A to scale the startup. This is changing. It costs money, but it's a disruptive technology, and it will pay off at the end. So
I'm going to make a check mark to that.
Yeah, so I think we have very good points. I would kind of throw in another angle to those answers from an evolutionary psychology perspective. So, so if you think about it, for the last millions of years, the reason why we have evolved to be where we are today is partly because about 90% of the humans don't take unnecessary risk, but you still have about 5 to 10% who will take odd risks. And those 5 to 10%, evolutionary speaking, were the ones who were not satisfied with their very idyllic Garden of Eden, where everybody had good food and were eating grapes off a comfortable couch. So these were the ones that said, oh, there's a hill there, I'll go across that hill, because on the other side, the strawberries might be bigger. And a few of them tried. Most of them used to get eaten up by lions. Nobody came back. And when the new ones were born, there were some mutants in that group which kept trying. So for the ones who did go over, didn't get eaten up by the lions, and managed to get across, and if there was actually very large strawberries, they were the ones who sort of went forward and became successful businessmen, and history recorded them. But the ones who got eaten up, nobody recorded them, right? But it's important that in any population makeup, you need to have those crazies, or basically mutants, who will continue to drive like the humans towards all sorts of weird tangents, which might become useful. So we will continue to have our Marco Polo movements here in Europe, and I think we are just part of that. How many of us will be eaten up by lions, only we'll know, but it'll be fun.
Very nice. So at this point, I have to ask, because we don't have a clock here, how much time do we have left until the next slot? 10 minutes? 20? 7, okay. There are lots of more questions I have to ask. A lot of them are really burning, but I can do this later. So we want to open this up for the audience to kind of ask a few questions. Before we do that, I will ask one last question, and then everyone has like 10 seconds to answer this. We start with you, and the question is very simply, what do you recommend the audience when they go home to either read, watch, or try out in terms of machine learning? What was fascinating and interesting in the last couple of months that you would recommend?
There was a great paper by Google DeepMind, appeared I think 1 or 2 weeks ago. This was about training or reinforcement learning applied in games, and actually the outcome was that the virtual agents in the game were able of learning some sort of a team playing behavior. I think it's a very interesting and fascinating paper, but yeah, so.
Very nice. Ronnie?
I still recommend science fiction.
One book in particular.
Neuromancer. You still need to read Neuromancer. You're not part of this community if you haven't read Neuromancer.
Okay, I can recommend a paper. It's quite a bit older by OpenAI, where they just try to integrate a human into a reinforcement learning loop, like giving a human judge the option to say which performance of a figure trying to do a backflip is better. And that is something that is very interesting, I think, because what we think could make a lot of sense is to automate this judgment of a human being feeding back into a reinforcement learning loop.
I would recommend 2 books. First one would be The Economics of Machine Learning. Forget the name of the author. I met him about a month ago, which is embarrassing. That really talks about this stuff that we are not really building a human brain. It's not going to take over the human race. That's something practical. And then the second book is Adaptive Markets by Professor Andrew Lowe, which talks about machine learning and behavioral economics in terms of the financial markets.
Very nice. Thank you very much. Let's give them a hand. And then it is for a couple of more minutes, I guess, time for your questions. Who wants to know something? How does this work? Do we have a microphone? No, I
think we have to take one.
Hey, thanks for the insights. Really enjoyed it. Do you have current results where you're proud of, which you want to share with us? Like something, I don't know, do you have like a 100% true positive prediction in markets or something? What you would like to share?
Maybe 1 or 2 persons answer because of time. Is it directed to anyone in particular?
So we have published recently a paper where we are trying to teach machines visual common sense. So basically teaching them how our world works. So things like gravity, object occlusion. I think it's a very interesting read. So it goes a bit further than just machines recognizing cats and dogs in an image.
So I think we have one paper, you can go to our website, that shows that using some of the probabilistic modeling techniques, what previously took 19 hours to calculate the delay of airlines now takes 2 minutes. That's on the website.
How are you focusing your efforts? Are you, for example, working on a customer's project and then you decide what the best technology is for solving that particular problem, or you have an idea in mind and you want to productize, or can you elaborate on this?
So I guess from my perspective, at least, it was, it always had to start with a customer problem and then you work backwards, but that's not the only way science works. But in our case, we worked backwards because we had to be very clear about what kind of decisions we wanted to make in those 2 different industry vectors we were after, and then figure out a common framework to make those decisions. But that's not the only way to go about it.
I think for us it was back and forth. So there's a certain set of technologies that you believe in and that you believe will be, performing well. And then you take this out to a customer and say, could you see, what's your problem there? And if there's a match, then that's what you go for.
Hello, my name is Ming. Thank you for your panel presentations. My question is, as we know, when we train the AI model, we are using very large amount of computing resources to do that. My question is there any lightweight AI model which can use the AI intelligence for very small devices and make large amount of small devices to collect intelligence and use it for certain kind of problems? Is there any new trend, new development in this area for kind of collective intelligence?
So I guess in terms of efficiency, the question is towards kind of efficiency of compute. I think there's a lot of innovation to be done there. I would say that one of the key issues where machine learning is very, I would say, compute intensive is mainly on deep neural net side. I think a lot of other areas are actually quite efficient. But that's where a lot of work is going on, all the way from deep Bayesian networks, that's one angle of it, and also combining Bayesian probabilistic modeling with reinforcement learning to improve the efficiency. Example I gave earlier is the paper we should be publishing of a 3 orders of magnitude faster efficiency. But I'm sure a lot of other people are trying that. You guys have anything to add?
So I think it would make sense probably to also have a literature maybe 5 to 10 years ago, because back then people were more concerned about, trying to implement stuff as efficient as possible. Currently, I think a lot of work goes mostly into neural networks and deep learning, and this computationally is just extremely heavy. But it's also fair to say, I think, that on the inference side, so when you want to use the trained models, so when you just want to do the inference, there's right now so much going on in terms of hardware development, right? So in the afternoon, there's an interesting talk by ARM about that. Every major chip manufacturer is working on their own AI chip that helps in accelerating neural networks and also other models. So I think there's a lot of things happening right now, but it's still, I would say, challenging to train a neural network on a smartphone. So haven't heard about that.
We're also, as a civilization, doing many things with neural networks right now that we really shouldn't be doing with them. It's just that they work so well. So there's a bunch of steps of next level AI that you're hoping we know already. That we don't know either, which really needs to come from very basic research. I think decisions play an important role. They are also hierarchization of knowledge representation. Today we sort of try to learn everything into a flat neural network, which is bonkers. We just haven't figured out how to do it more intelligently.
Yeah, I think that was a very important point.
I think there's some
it does work very well.
Some kind of like waves in machine learning. So with regard to how much feature engineering or whatever it is actually happens. So for the last years, it was like, okay, just do end-to-end deep learning, don't care about anything. But the thing will take more steps towards like building things intelligently with maybe human knowledge to somehow do what was called feature engineering. I'm not sure if it's called in the future like feature engineering, but I think we'll have a kind of, another wave of how we do stuff.
Very nice. So unfortunately, time is over. So this is the moment where I thank you guys and you guys. Maybe a last applause for the whole panel and for this discussion.
Also a round of applause for our moderator.
Thank you very much. And as a small shout out, you guys will be around, right? So approach them when it comes to startups and how to get in touch with industry and so on, and machine learning. Also approach me. We all will see where we can help.
Danke.
Awesome. Thank you very much.